Hello everybody and welcome to another Mystery Box Function Challenge. In the purple mystery box there is some math and your challenge is to figure out what it is. You can try this out on your own by using the link in the description, and when you think you've got an idea, come on back and see if we get the same thing. All right, let's start with a 0. Right, so 0 gives us 0. How about a 1? So 1 gives us the infinity error, and so that usually makes me consider rational equations as a possibility, so we'll just keep that in mind. Let's get some more points so we can see what this looks like. How about 2? And if 1 is our asymptote, let's look at 3/2, so something a little closer there. Okay, and let's keep going out. I'm going to go out a little further. How about 6? Oh, whoa. Okay, it's looking a little confusing. How about 9? 9 is off, just off the graph. I'll throw in a 4. All right, so I suppose this could be one arm right here. I'm going to sketch in where I think the asymptote is, because this graph I think is going to be a little harder to make easy sense of. So there's our asymptote. And so we could have an arm going up way up here and out in this direction. In fact, let's look even closer to 1. So let's just put in, oh, I don't know, a 1.8. Oh, whoops, that's not what I meant. A 1.2. And that's up at 7. Kind of can't see it because of where I drew on the screen. But yeah, it's hugging that like an asymptote. So let's look at this on the other side. First, I'm going to put in 1/2. Okay, so that's down there. And how about a 1.8 as well here? I mean, 0.8. Okay, and let's go into the negative. So -1. -2. How about a -5? Okay, so we've got an interesting looking function here. And what you notice is that we have a vertical asymptote at 1. And the easiest way you could get a vertical asymptote at 1 is to have an x minus 1 on the bottom. So if you put in 1 for x, this all blows up to 0. So let's just throw that in there for now. The other thing we have here is a slant asymptote. So there, I think, is our slant asymptote. It kind of looks like it's close to, or maybe is, the line y equals x, or close to it. So it's right on. So at 0, we actually got 0. So maybe it's close to the line y equals x, maybe y equals x plus 1 or something like that. So let's see, how would that happen? So you get slant asymptotes when the degree of the equation is bigger on the top than it is on the bottom. If this is, the most simple thing would be this x minus 1 on the bottom, then we'd have to make this an x squared on the top. And actually, before we go any further with thinking about how to construct the function, let's just test this and see if this is going to work. I mean, if we put in 1, of course, it would work. It would give us infinity because the bottom would be 0. If you put in 0, it would equal 0 because you're going to have a 0 on the top. What if you put in a 2? So that'd be 2 squared over 2 minus 1, and that's 4 over 1, and that is 4, so that works. Let's try, I don't know, let's try a -1. So -1 squared over -1 minus 1. So that is going to be +1 over -1 minus 1 is a -2. And what did we get? Yeah, we got, my graph is a little off here. This one goes to this one. Yeah, we got -1/2. So that seems to work. So I think we've actually got this. I'm going to go ahead and take a look. Yeah, x squared over x minus 1, and let's graph that. Those beautiful curves with the slant asymptote. Well, how did that go for you? Did you think rational function? Let me know. Thanks, everybody.